General Protocol Spaces. Banking on Freedom.
All right, everybody, welcome to General Bowl 34 of N, multi-sig, as you would appreciate, Jason. And we have a very special time this one. We're going to be talking with Jason Dreyzehner, who is the author of many things, but currently author of the VM, the Virtual Machine Limits chip, the Cache Improvement Proposal, and the Big Ints addendum or appendix chip, which is out there also and very relevant. And this is going to be a format of an AMA, and Ask Me Anything. So, of course, if you'd like to come up and ask Jason some questions, please raise your hand or send me a DM. Or if you can also post them on Reddit or Twitter, I'll be trying to monitor those while we talk and try to make sure we get out a lot of questions and see what people have to ask and see what Jason has to say. So welcome, Jason.
Thanks for having me.
All right. So I have a long list of questions that I made up, and then I have a long list from Reddit, and then I have some from DM also. So I have all those ready, and I'll just kind of be dripping those into the conversation as we go. But I thought we would just get started with whatever it is you would like to frame things as. Like, how do you want to approach the AMA? What would you like to talk about?
I'm up for anything, and even outside of the chips, other chips and stuff. Yeah, fun to talk about this stuff.
Yeah, for sure. Yeah. Not just the chips, but of course that's the most topical thing here. So I'll be a little bit distracted trying to drag people in during the conversation. So let me get started with just right off the bat with a technical question to make sure that everybody who's listening gets totally turned off and just walks away right at the beginning. So the question that I'd like to know is, there's a very common discussion on these chips, the VM limits chip, about density. And this is the VM limits chip, right, is about the Bitcoin Cash blockchain can do code, right? You can run programs as part of the locking and unlocking, really as the unlocking of a coin. So you've got a coin with 1.5 BCH on it, and you can put rules on that coin. What does it take to unlock and spend that? And what are the rules around spending it? And so there's a programming language and a system for doing that. That's the virtual machine, the Bitcoin Cash virtual machine. Now, this chip that's for upgrading the virtual machine limits allows us to do more with that machine by opening it up and saying you can write larger programs, and more or less. And within that, in this chip, there's this concept of density and output-based density, or transaction-based density, or input-based density. So could I ask you to explain what is that density at a higher level, like for people who aren't into all the low level details, and how does it compare to what was happening before?
Yes, thank you. Yes, so at a super high level, transactions take some computation to verify, and every single node on the network has to verify every transaction, right? Every fully validating node. That is how it works. So when the chip talks about density, it's talking about, if you kind of imagine that the amount of computation required for a particular transaction has some number, and we want to keep the density of that number pretty consistent, and we want to keep it below some level that is safe, so that every node, within the specs that we want for our node ecosystem, every node can validate every transaction and not use too much of its CPU. And the chip goes on in detail about exactly where we are right now, and our what I call our safety margin for the virtual machine. Our safety margin right now is between 10 and 100 times what our virtual machine uses, which means that on a computer that is just any computer bought since 2017, very standard consumer hardware, with typical it's going to be typically like a desktop computer is what we're thinking about, but but certainly more modern phones can do this stuff too. I mean, we're not talking about too much of a difference in the performance capabilities here. But between in our current protocol, our margin of safety for those very typical consumer devices, and the benchmarks are again since 2017, is between 10 and 100x. And what that means is that on those typical consumer devices, their CPU utilization, if they're running Bitcoin Cash in the background and Bitcoin Cash is cranking out the max size blocks filled with the worst case possible transactions, they should, at least only due to the virtual machine's performance, they should use between 1% and 10% of those machines' CPU available CPU bandwidth, sort of. So we're in a very, very safe spot right now, even on very typical consumer hardware, even at 32 megabyte blocks. And even if those blocks get quite a bit larger, they can get about 10 times larger before we start to hit CPU densities that would challenge the weakest of plausible computers that are running Bitcoin Cash right now.
But of course, one caveat to that is that until we can get UTXO commitments, which a lot of people in BCH seems to want, IBD initial synchronization would be an issue. So that margin isn't that.
Yes. Yeah.
Well, I mean, it's comfortable, but it's not that comfortable.
Yes, I certainly agree. Yeah, I think it's a good point. Thank you for bringing it up. So from the perspective of this chip, the part of the system that we're looking at is the virtual machine. And so, the chip tries to avoid making it any worse by carefully computing exactly what the worst case is now and figuring out what that density is. And so when I talk about that safety margin, I said the safety margin specifically for the virtual machine, assuming all else equals, between 10 and 100x. But there are some details about if you're using, for example, a pruned node and then what it takes to get up to the initial sync. There are different nodes that do things differently, and there are actually safe ways to sync to the chain tip without, of course, verifying all of the past scripts. So it is still true, despite the fact that there are other performance requirements. It is still true that our actual safety margin for the virtual machine is still between 10 and 100x, because there are alternative trustless ways to get to the chain tip. And in fact, even BCHN does that. We do have. There is no hypothetical, there are hypothetical reasons. There's no practical reason to revalidate every script in the past history of Bitcoin Cash if you have just downloaded a Bitcoin Cash software implementation that is implementing modern rule sets, right? If you've just downloaded that piece of software, you inherently are trusting the code, or you've just compiled from source that piece of software. You're trusting the thing you compiled from source. You're trusting that source to be correct about some past understandings of what happened on the chain. And in practice, that means that really you only need to validate maybe the past year or so of transactions, because those are the transactions that have happened since you are certain that the code you're running would be compromised if anything else was. The code you're running is more likely to be compromised than the things behind it, right? So you have to actually judge your security perspective if you're trying to evaluate initial block download questions. But fortunately for the limit chip, we can also avoid dealing with other parts of the system. We can keep the scope of the chip itself really, really well contained to just the virtual machine. And with just the virtual machine, our safety margin is truly between 10 and 100x, with a slight caveat of if your computer is very, very slow at reading from the UTXO set, which is its own. That is probably the real performance concern for most nodes. The real performance concern is not CPU usage, but for the purposes of this chip, CPU usage is the guiding principle. We need to make sure we don't make any worse, because we don't want it to become the worst case. We want the worst case to stay. It's the current worst cases of what Eminem was saying there, the initial block download questions, and then also essentially reading from disk, the cost it takes to read from disk in various places. So yes, it is not sufficient to say that because we have a 10 to 100x safety margin on the virtual machine, it is not sufficient to say that we can safely 10x or 100x the block size and not lose any computers, right? Because these computers run on atoms. But for the purposes of designing the limits for the virtual machine and talking about specifically the computation requirements of validating a transaction, the safety margin is 10 to 100x. Let me now that we've dived very deeply in there. So density, the original question, density then is kind of it is the real practical actual density of required computation in transactions. And when we talk about density-based limits, we're actually maybe leaving out a word. We're talking about explicitly defined density-based limits, because there is no such thing as a limit that is not density-based. It is a complete fairy tale that you could have a limit that is not density-based. Our existing limits are statically specified, but they are still density-based. The fact that you statically specify them makes them incredibly erratic and subject to change based on seemingly unrelated differences in the system. For example, reducing the minimum transaction size approximately doubles the worst case scenario in terms of computation, because the worst case scenario needs to be packed into sets of worst case, essentially packed into a worst case block. And if before you could only pack in approximately 201 opcodes across multiple inputs, and it depends on the CPU and the architecture and where you're running it and what you're testing specifically. But all else being equal, we can very loosely generalize that if you reduce the minimum size of transactions, you increase the overall potential density of the worst case transactions in a worst case block. Now,
hold up. Let's go back. Let's take it a little bit higher. So density generally means like something per something. How much of something do you get per something else? So at an even like higher, more abstract level, like what are we saying with the density? Like, what do you get? What are you getting for what? What's the A over B like for this?
And I'm sure that this is even harder for non-native English speakers. So I apologize. The density being, the CPU usage over the number of bytes in the transaction, because our real limit is the number of bytes that end up in a block. And so everything here happens sort of before the block size limit. And the block size limit creates an actual practical limit on the worst case resource usage of nodes. And you want it to be set somewhere where it's well above real usage. And, in our case for Bitcoin Cash, we want it to be set somewhere where it's well above real usage. So, it can handle spikes in demand, but also it doesn't require node operators to allocate, truly excessive amounts of resources to sit around idle while nothing is happening. And so like
a certain upgrade that we just activated.
Yeah, that's exactly right. So within the upgrade that was just activated, the ABLA upgrade, adjustable block size limit algorithm, our system now increases that maximum requirement at a worst case rate of 2 times per year, 2x per year, and then there's some additional stretching where it can increase at faster rates than that, but over the course of a year it can't beat 2 times in a year, which is really excellent for capacity planning. It's essentially the sole purpose of a block size limit is to allow node operators and infrastructure providers to capacity plan. And if you can't capacity plan, if the block size limit is unlimited, if tomorrow you can go from being a blockchain size of whatever, a terabyte or something like that, and it's much smaller on BCH right now. But if it was hypothetically a terabyte, and then all of a sudden somebody could just crank out X gigabyte blocks over the course of 3 weeks or something, all of a sudden you are significantly changing your costs for the whole year, in the most non-trivial part of your costs, if other than human resources. Like if you're a Bitcoin Cash business, your other most non-trivial cost is straight up your computers. So it's very important to have a limit somewhere, that is the worst case, and you want it to be high enough that it doesn't hurt real users. You don't want real users to have to bid for block space, but you also don't want to reduce the viability of running a node, or reduce the viability of running infrastructure, by making it impossible to plan for the possible increases. Sorry.
Sorry. I was just going to say, as an engineer, I love hearing this. This is like music to my ears, right? That how BCH really acts as as somebody said recently, like the engineering blockchain that actually pays attention to the real world and how it works. I love it.
Yeah,
atoms, as you said, they run on atoms. You have to recognize these things.
Yes, it is. It's easy for some people to get a little bit heads in the clouds, and it's important to recognize that all of these things have to run in the real world by real businesses, and on actual atoms, and at least for right now. So yes, in the context of the limits chip, operates in a space that most people are not thinking about, because it truly doesn't matter in our current system. Like, nobody is terribly concerned about the overall CPU usage, because it has been gotten under control in the past. There were actually issues in the past, and Bitcoin Cash had, for example, an upgrade in 2020 that was important for CPU usage for some workloads on some machines, for reducing signature checking. But so that work built into the limits chip quite a bit. There was, the limits chip would have been another 10 times harder if we had to also get signature checking under control, so to speak. And so that it's nice that that's already done, and that we are kind of working safely in the shadow of that. That's still the worst case. So we can just allow more opcodes to be used in other places, and there's some hashing technicalities. We can prove that there's an asymptotic limit of the worst case plausibly non-malicious hashing contract. But those are technical details. To have an understanding of what's actually happening, you first recognize that our real resource limits are just like way beyond what we're talking about today. And there are definitely people that get that for the context of the VM, that they are our actual resource limits are really like how hard it is to read from disk, and then also bandwidth is the important usage-based cost of operators, and there's some other things, and those are actually detailed in the rationale also, just to kind of summarize some base understandings of where we are operating. But so for the purposes of the limit chip, we are working with trying to figure out how to make the virtual machine a little bit more sane about what it allows and what it doesn't allow, by essentially giving honest contract authors the same computation that we already give the most abusive possible contracts. That's the core thing to know, that the most abusive possible contracts right now use about 243.9 times what we would otherwise give honest contracts in a. I'm a little bit oversimplifying there, so check out the chip. It's in the very top rationale. What honest contract authors actually get. So you can kind of think of it as like honest contract authors right now only get to use about 1% of the VM, and abusive contracts are able to use 100% of the limits we give them to do nothing. So it's just crazy to set the limits this way, just absolutely crazy. And you can retarget them to allow honest contract users to use 100 times as much on, for some statistical sample of those. But you can give contract authors a huge amount more in the best cases, and even in the least cases where we have not, where it's not easy to extend those limits to those contracts right now. We've done the most conservative possible thing. So there are places where still you don't get to use as much compute if you're doing one particular type of thing. But those are all easy to identify, clear decision points, very extensively documented in the rationale, and it's so that we can be sure that various VM implementations do not have to implement specific optimizations. We want to make the protocol maximally easy to have a safe virtual machine implementation, at least in this upgrade. There might be future upgrades where people where proposals want to really push a particular limit to its max, and in those cases, virtual machine implementations might have to have a specific optimization. And there are 3 mentions of that in the rationale. You can find the 3 places where we choose the conservative thing rather than requiring an optimization. And notably, one of those optimizations is required by Taproot. And we chose to take the conservative option.
Oh God. Yeah, let's not go into the silliness of Taproot and SegWit. So if I boiled that down, I would say, and hopefully I'm not too far off here, this VM limits chip more or less allows a budget per block space. I know that's not exactly right, but let's say for simplicity's sake, it allows a CPU budget per like CPU memory, whatever, like a computing budget per block space. That is for a general user, as in a developer who's making a smart contract, right? That is more than 100x larger than what they would normally need, because it's set at the kind of limit of what you could possibly do that's not malicious. So it's like more or less 100 times larger than what you normally need. And that limit is then further 100x lower than kind of the safe limit of reasonable computing that you could possibly ask. Is that a decent?
I would say the second number is not 100x. I'd say the safe number is 10x, because that's the bottom 10x. Of the range. But yeah, so it's we're talking about something that is we're currently giving a contract authors something like 100 times less than what we can give them, and our safety margin above that is another 10x. So yes, and that's not even the only set of safety levels of defense in depth is the technical buzzword, but you can find in the rationale more about that. But yes, that is a great summary. We are right now, contract authors get 100 times less than abusive contracts, and even those are still probably somewhere north of a 10x safety margin even right now.
Okay, perfect. That's very good. And then additionally, probably don't want to get into this because we'll run out of time, but I just wanted to mention that not only that, but the way the new VM limits are set up, you now, after the VM limits chip is done, you have room to further open that space up for non-malicious contract writers in a kind of granular way, where you can say, yeah, you can do these things that make a lot of sense for P2P electronic cash, and these things that don't make any sense for P2P electronic cash you can't do. So it's much more granular after the VM limits upgrade, how you could potentially move things in the future to make more room for smart contracts. Yeah,
exactly. Yeah, and I see Callan kept putting a hand up there for a moment, and Callan being a developer for BCHN, our most popular mining node, and definitely our a very important implementation. Callan, what did you have to say?
I was just going to sort of summarize your point from just again in different words, because I think it's really important to realize that like the worst stuff, the worst possible transactions were possible, like to abuse the network in a way. And those are sort of being plugged up now by this, but you're also at the same time you're letting like the legitimate contract authors that might want to do stuff do more. So, which I guess you said already, I don't know. I mean, I just want to underscore that point, that the limits chip actually also constrains the malicious stuff while liberating the non-malicious.
Thank you.
That's all. But I mean, you said that already. I just wanted to just repeat it.
I didn't talk about specifically. Callan is talking about the new standardness hashing limits, and we can prove that the worst that an honest contract could possibly want to do in hashing is somewhere below the asymptotic limit of a plausibly non-malicious contract, and that is 0.5 hash digest iterations per byte. So it's there's a lot more discussion of that specifically in the chip. But what Callan is talking about is that this chip does make some standard transactions that are currently technically that are currently possible to broadcast on the network and have other nodes rebroadcast. It makes them non-standard so that they're only valid if found in a block. And that plug, it's basically right now, just with where our statically defined limits are, they are currently about 7 times higher than would be plausible for a non-malicious contract. And we can prove where that number is, and that is where the standard limit is following the upgrade.
Awesome. Yeah, that was a good point, Kellen. Yeah, that hadn't been covered explicitly. Thank you. Now, CipherCat also had his hand up, or at least Twitter tells me that you have your hand up, but that doesn't always mean that you actually have your hand up. But Cypher, did you have
I see it too.
a question about it?
Oh, I was just going to say, I saw the BCH podcast yesterday, and it was great. Yeah, I guess what I wanted to ask is, because I think what we're kind of seeing here is you're explaining something from a very technical level, and then we're seeing kind of mediation with the AMA thing here, and I think that's really great. One of the things that I'm trying to kind of, I guess, explain better is the adaptive block size thing, because whenever I say this, either two things will happen. Either they'll get it immediately and they'll be like, "Oh yeah, adaptive block size, that sounds cool. Why weren't we doing that this entire time?" Or they will hear the 2x argument, and they'll immediately assume that once per year we just double everything and destroy the whole economical stuff that we were trying to do. And I'm trying to explain that this is a sweet spot, and I don't know how to say it better than it's a sweet spot we're trying to target, and that it's autonomous. And I try to say that, and they're like, "What do you say? What does that even mean?" And I'm like, "Do you have a way of explaining it that's better?"
I don't know if I'm going to have a way that's better necessarily than anybody else. Quite honestly, the only reason anybody cares at all is because of historical events, right? From the perspective of most users, this is the kind of part of a system that absolutely nobody cares or knows anything about except for the very technical people. So it's almost like an historical anomaly that anybody in Bitcoin Cash would even care about what the block size limit is, just like people would care, for example, about what the density control length calculation looks like. I mean, it's just
generally it's becoming more
density control wars.
Yes,
right.
Oh man, that'd be funny.
Dense, better to program, extremely efficient. It's what UTXO should have always been, all that kind of stuff. But that's stuff we can tell people, but it's damn it, I appreciate this stuff so much and I wish I could explain it better.
I get it. I totally get it. Yeah, it's yeah, and obviously there are some technical discussions that quite honestly are simple enough that they can become wider political arguments, and the block size is one of those technical discussions. The block size is basically the lowest common denominator possible technical argument to talk about, and so that's why it is talked about like that. It's easy to talk about, the block's got to be bigger, or they got to be smaller, or whatever. It's easy, and it's easy to have holy wars about something that seems like you can have a strong opinion about it, but nobody, very very few laymen have strong opinions about the precise base operation cost or the precise calculation of the density control length and things like. And this is just another example of where as the complexity of a technical topic increases, the rigidity of the debate about the topic falls.
The bike shedding threshold.
Yes, right. And all the way to the very, very bottom is the lowest common denominator kind of arguments for religion and politics and things that you typically don't want to turn into arguments. And the block size is somewhere closer to that category of arguments than it is in the wider perception of the cryptocurrency space. Now it shouldn't be, but because it is such an easy thing to have turned into that, That is what it has become, versus a number of other things that absolutely nobody, except for, essentially people on this call and maybe a few people in the BTC camp and maybe one or two people in BSV and one in XEC. I mean, there are certain technical elements here that there are maybe 1,000 people in the whole world that care enough to know anything about them. But the block size limit is just one of those things that has broken out of that category and has a life of its own in the wider zeitgeist.
All right. Let me. Thanks. That's a tough question. And I think it reveals just that there's an open-ended need for better technical communication. Right. That's the normal phrase for what you would do here, which is take very technical topics, or in this case, like the minimal technical topic, and make sure that those are explained and come across very clear to a larger audience. So yeah, that's something we need to do better. And there's some room, right, for people who want to take action and do something. Technical communication clearly is an open thing. So thank you, CypherCat. Let me move on to another question here, since I don't have another speaker right now. So Mathieu, who has done many things with Bitcoin Cash, most publicly Cashanize, and then also working on CashScript. I'm sure you know him, but just for everybody listening. But he had a question, which was, can you expand on how the opcode accounting and BigInt changes impacts the ideas for future math opcodes, such as EXP, that's the exponent, log, root, and he said pow. I don't even know what the pow. I don't know what that operator is.
Just raising power.
But what's EXP? But if that's what's EXP then? If it's not power?
Yeah. Okay, actually, good question. Okay, you already said that. Okay, that's funny. I just responded that like seconds before I got on this call.
Nice.
On the Reddit AMA. Yes, but let me talk about it specifically. So so I actually can read the comment, that question here now, which is nice. And it's funny, when I read it before, I did not see that there's a repeat there. But
sometimes EXP means the Euler's number, the Euler's exponent, but I don't know. Anyway,
yeah,
I don't think we have Euler's.
Yeah, funny. I actually did, my brain autocorrected and just removed that, and I didn't even parse it before. The question was, how would these things be significantly easier to add, or same as before, and how does BigInt change things? And I said that yes, far easier, and yes, that native BigInt really opens the field for some of those math operations, which will certainly be useful in various contracts. And it's really valuable for people to just understand that Satoshi chose to use a number encoding in our virtual machine that makes it particularly easy and efficient to work with big integer numbers. So Satoshi originally, published Bitcoin with completely unlimited big ints. The only limits were applied elsewhere. They weren't applied to the numbers at all. And so the proposal with BigInt is actually also to remove that extra number limit. The number limit came in July of 2010, when Satoshi was just, in a series of emergency patches, applied lots of limits in a lot of places to try to get that density down, to get that computation density down, so that the worst case wasn't going to kill Bitcoin. And so he most certainly saved Bitcoin at the time with those limits, and they were clearly not hastily applied. You can actually tell that he was careful about tuning some of them. So he was thinking about it, deeply, and some of them are. Yeah, I was a little bit surprised to see that when in my naive JavaScript implementation that uses WebAssembly for the hashing, that I got pretty similar performance numbers across the worst case that hit 2 different or 3 different limits, and it kind of depends on what you're doing. But it is notable, and I think probably very likely that Satoshi was doing some careful benchmarking and picked numbers, very carefully, in a way that is also pretty easy to upgrade. So even the limit system we have right now is pretty genius for for the situation Bitcoin was in at the time. They did not have 3 years to work on a proposal like this and ruminate on it and think about the exact implications of each little detail. Satoshi probably knocked this out in a month. In the month following when Gavin first asked him about it on the Bitcoin Talk forums. So, for a month's work, the existing limit system is quite brilliant. I cannot judge it. But even in that, it makes it easy to upgrade because we can be definitively sure about the worst case in some of these places that would be so much. It would have to be combinatorially more difficult to make statements about various parts of the limits if he had made them even a little bit more intelligent, like these density based limits. So I wanted to get that out because it is important for people to know, the first thing one of the first quick takes you can have about the virtual machine, and most certainly was my takeaway when I was first learning about it, was like, man, those numbers are weird and silly. I don't know what Satoshi was thinking of there. And then also like this 201 opcode limit is just silly as well, right? And a lot of people are still stuck there, and they've been there since they first heard about Bitcoin in 2013 or whenever, 2012, and that was the zeitgeist at the time too. And I'll say the only other thing that the zeitgeist of the development community includes about the virtual machine is that the only thing that almost all Bitcoin developers know about the virtual machine, because it's like the first sentence of the description in lots of places, and is that the virtual machine doesn't have loops. And what's hilarious about that is that the first system of limits that Satoshi designed was to remove looping. That's it. and clearly he's at this kind of academic stage. Clearly he was thinking. And was kind of proud about and talked about it in various places. So I can't say clearly. I should say my hypothesis is that he was probably working alone, because if he had tried to explain it to somebody else, they would have asked about what about this. But he thought that taking a sort of academic approach to limiting the virtual machine would be sufficient, and so just removing loops means that the virtual machine is. Every contract is technically terminable. There's no way to loop infinitely, and so those are sufficient limits. And for a year and a half,
not just way to limit, not just low way to loop infinitely, but right, you don't have to worry about it. Sorry. Go ahead.
Yeah. So for a year and a half. Those were the limits, and then essentially Gavin brings it up on the forums, and clearly Satoshi's working on for months before now already. He's trying, and since he released it, he's spending a lot of time trying to harden the client and remove potential denial of service attacks and things like that. And Gavin's like, hey, what's this script thing on the Bitcoin Talk forums? And his first post is real proud about it, and then 8 hours later or something like that, my reading into it, this is not, other people will have different impressions, but my reading into it is that he then 8 hours later or whatever he's going back and looking at the script system, and he's thinking about all this denial of service stuff he's been working on for the past 6 months or so, and he's like, oh my goodness, this is a mess, this won't do. And then about a month later, he starts sneaking in patches, and he continues sneaking them in until quite literally the day after the day after his last post on Bitcoin Talk forums, and when he disappears following the WikiLeaks stuff. So he clearly starts trying to be a little bit more liberal in how he set the limits pretty high in his first pass, and then he takes another pass and he just slashes out big integers altogether. He cuts them all the way down to 4, and he clearly tries to. He's not quite certain yet about how upgrades might happen. He's just added the op-nop 1 through 10 opcodes. He's clearly got a good sense for what soft forks and hard forks kind of mean. but he's uncertain about whether or not he's sort of breaking the social contract of his system by increasing these limits again later. And so he's trying to set them as high as he can. But then when he cuts the numbers down, he cuts them all the way down to 4, but in kind of a clever way so that they can their results can overflow. He removes opmul and then he allows add to overflow into 5 bytes so that a contract that's working with 4 bytes wouldn't have a different result if he later pushed it back up to at least to the 5 bytes. But yeah, there's clearly like the beginnings of having the understanding and sense that we have now today after 14 more years of people talking about it and arguing about it, and the things that we sort of take a little bit for granted now about things that what we believe about consensus and how rules apply in soft fork and hard fork situations, and whether or not the idea of standard transactions was developed. I think by Gavin. I'm not entirely sure, but merged by Satoshi before he left, and then Gavin was the lead of the project after Satoshi left. But yeah, so I digress. Yeah.
No. I wanted to say before you maybe continue, but so you were saying earlier that he approached it from an academic perspective somewhat, but I think this also reveals that he was so serious about it that even if Satoshi was from an academic context or whatever, he was still experienced and acted as an engineer, because these are engineering decisions, right? Where it's like, okay, wait, I added this system and this system could potentially break the thing that I've made. So let's put some realistic limits on it so that it doesn't break the thing. That's pure engineering, right? So I love that whatever Satoshi's background was, it also approached it from an engineering perspective as well. And just like from a practical perspective of making things work.
Yeah, and thank you. That reminded me that what I wanted to mention was that something I find kind of funny in the historical record, essentially, is that probably a great deal of Bitcoin development, Bitcoin Cash also, was guided following Satoshi leaving 2010 or so, was guided by the fact that he did not delete a comment in his first emergency patch. And of course he's not going to delete it because, it's an emergency. He's sneaking the stuff in, and he's not like adding these limits and then thinking, oh yeah, but within these limits, somebody later is going to want to add loops. Like he is in emergency fix mode. But the fact that he left in a comment that pre-existed him publishing Bitcoin, he left in a comment that said the C script, I think it says C script is a forth-like stack-based language. It has no loops. It has no loops is the end of the comment. And in some way, having that comment at the top of that file was like the lowest common denominator way of understanding what you were looking at. And so most people read that comment, and it essentially guided the thought process of all future Bitcoin developers about the virtual machine for a decade, and still does. It still guides. It still guides most developers,
right?
Most developers see that comment, or they see the downstream results of that comment. The very top sentence of the Bitcoin script wiki page since like 2011, it says the very same words that Satoshi wrote in that comment. But people have to recognize that like that comment was written when the limit system was to not have loops. That was the limit system. There was not another limit. So
it was taken as
he had removed that comment
instead of as just a practical note, right?
Yes.
Yeah.
Yes, exactly. So if he had removed that comment when he changed his mind, and started adding other limits when he recognized that of course looping is not a meaningful limit, because you can just duplicate, concatenate. I mean, you can make the virtual machine in his original version of Bitcoin, take whatever's on the stack and duplicate it and add it to itself and duplicate it and add it to itself until you just run out of memory and everything crashes and everything burns, right? And it's easy to do that, right? Like the when you make a number go up to the power of whatever, when you get up into those higher powers, you know, going from 10 to 30 is pretty significant. And so, like, no matter what, you can have a really, really concise script, even without loops. You can have a very concise script that effectively takes all of the memory you could possibly have on any computer that humans have built yet. Certainly within the limits you had before.
For Taproot.
What's that?
And make a JPEG out of it for Taproot.
Yeah, okay. I thought that's what you said. I wasn't quite sure. Yeah, okay. Yeah, so I find it to be like historically funny that comment probably had I mean, that comment very, very well may have first tipped some of the people that later became the small block side of Bitcoin. It may have like kind of misled them. And in fact, I would maybe even phrase it a little stronger. I personally believe it did mislead them because their later ideas about covenants and things like that are all just kind of downstream of this general technical view. It's ideology sort of that thinks that not having loops is some sort of holy part of the system. This
is great. It's another one of those places where we can say we recognize both because there's a common perception that Satoshi was just a hacker, just throwing things together. And Callan we've discussed this in the past, that no, he was absolutely not just throwing things together. He was a very talented person who made this system called Bitcoin and integrated all kinds of ideas without turning that into a religion and saying, and this is the thing we need to do next to achieve the actual goal for things. So yeah. I love that aspect.
Yeah, Jason, totally agree.
Let me go back to the specific question. So
real quick.
Yeah, go ahead.
I should just add also that in the same way of all the stuff we were just talking about with the loops thing, another kind of funny thing about what Bitcoin developers think about with the system that is directly related to this proposed upgrade is that a lot of Bitcoin developers, first see the system and are confused and bewildered at why the virtual machine represents numbers the way it does, because most developers have never seen numbers represented in sign magnitude format. Most modern developers, right. There was a time when most developers had seen them all, and still, if you take a computer science course, you're going to see them all. But like in actual practice, in actual practice, a lot of people even that went through computer science courses and come out the other side, and then they're working in the industry for a little while, they have forgotten that lesson or whatever, and it's like it's treated as a historical lesson in most cases, unless you're dealing with a big integer arithmetic, and so people's impression of the virtual machine number thing is that like Satoshi had some sort of like holy reverence for this one type of number format, and he's just like he's one of those little Indian guys, and he's one of those big Indian guys, and all the people, everybody else went little Indian or whatever. So it's just it's really easy to have this perspective that like, oh yeah, man, those numbers are just messed up. I wish he hadn't done that, but like, thank God he did it that way because it's so much better. So yes, I want to note it's so relevant for this upgrade that because he chose to lay them out that way, we can actually get slightly better, closer to the theoretically optimal performance out of contracts that people write and broadcast on the network, rather than having to add on a special opcode for every type of thing that we do that uses large math.
Right. I think that ties back to the old history where computer science used to be more closely tied to electrical engineering, where, registers and the way the things actually happen are executed was relevant. And today it's, I wouldn't say it's less relevant, but it's much more abstracted and people are less aware of it. But yeah, at the time that it was being made, he was clearly aware of things that mattered from the low level to the high level, right? It's pretty impressive.
Yeah. Yeah, for sure.
Okay. Let me ask a different question. Oh, wait. No. Let me ask this question. So in the current the benchmarks that I've seen, addition is the worst case for things. Surprisingly, I think that's right. And then Matthew was asking exponent, log, root. Would those be worse? Would those be better? I mean, would those be worse than the current worst case, or?
No. So because we kind of get computation under control in general, it's very, very easy to add those other opcodes because we would cost them in terms of computation. And I should talk about specifically why it's not a gas system now, because I've now said the word cost. It's definitely not a gas system. I'll just say that right now. But we can cost those operations based on their time complexity, and their worst case time complexity and the least optimized implementation we want to be easy to build on our network. That's like the actual answer. But it's easy to have a surgical upgrade that adds a single opcode with a single way of computing how expensive that operation is. And most of these math operations will exponentiation will have a time complexity that is definitely not addition. But it's possible to optimize. If you get to optimize an exponentiation, you can do, for example, exponentiation by squaring, which is a lot faster than if you were to emulate it in the contract language. If you were to like dupe and mul, dupe, mul, dupe, mul, you can do exponentiation by squaring in the contract language also, but you're wasting a lot of bytes. And in practice, like going in and out of the overhead and going in and out of numbers, if your VM implementation isn't optimized to have that cost be essentially zero. There are other things that get in the way of best case performance for those computations, which, because we would have native big int, we can get the very best case performance even out of stuff that would have types of algorithms that are difficult to optimize in a generalized way. So like opmul has lots of different ways you can do a slightly faster multiplication based on what inputs you get. And a contract can't reasonably, it would be completely unreasonable for a contract to try to have multiple implementations that are, one is slightly faster than the other if this input is this size or whatever, because a contract just wants to get the answer, and a contract author is not trying to minimize the CPU impact on nodes. That's the job of the protocol. And so with native big ints, we can get very, very close to the maximum theoretical performance of very large multiplication, for example, because VM implementations can use, the Suba? Is that how you say it? Multiplication. There's an algorithm that is the optimal one. I'm actually scared to butcher it. But I'm realizing I've not said it out loud yet. So there are different ways of multiplying that are faster in different cases, and heuristics to decide which one to do. And optimally, if our protocol can allow for virtual machine implementations to do those optimizations, that's an unequivocally good thing. We don't require it at the protocol level, but it is pretty cool that contracts that are written for Bitcoin Cash now are going to have bare metal performance for these very large calculations that if you tried to emulate them, they for sure, even on the most advanced virtual machine implementation, would likely only approach that performance. Like even the most advanced virtual machine implementation would have to read the contract code that was emulated and try to reverse out what it was emulated from and do a just-in-time compilation like JavaScript does, like is done by V8, to execute the fastest possible way. And if it's some sort of heuristic, it might have to have some sort of branch prediction where it tries to do the calculation. And in practice, that would never be optimal. You would just leave it less complicated. You're not going to want to make consensus code complicated with that kind of stuff. But by having native big int, the complexity of that is super, super simple. Every single big integer library out there that's used in production does these optimizations, because you wouldn't want to use a big integer library that doesn't do your math as fast as it could do it. And lots and lots of academics and other financial institutions, lots of people are using big integers, and they're all using various libraries that have been, in many cases, some of them are decades old. So our virtual machine implementations can use that already very well tested, well optimized, set of libraries and built-in programming language primitives. JavaScript has built-in big ints now. Python obviously has had big, arbitrary precision arithmetic for a long time. There are lots of programming languages that have access to built-in primitives. And then in the C++ world, BCHN is using libgmp, which is also currently being used by lots of other cryptocurrencies that do big integer stuff. So, it's currently being tested in consensus critical places by other cryptocurrencies. It's just, honestly, it'd be crazy not to take advantage of bare metal performance for math. And it's amazing that we can get bare metal performance essentially out of contracts that people broadcast in transactions. That's awesome. For a long time, a lot, based on some of those bad ideologies that we were talking about that promulgated, based on maybe a comment or the weirdness of the numbers, based on those bad ideologies, we never thought that it was going to be possible to get that kind of performance out of the contract system. We thought the contract system was always going to be, slow and high overhead, and that the only way to get really fast stuff was going to be to do a new special opcode just for the fast thing and optimize that a lot. And that is just not the case. It is by design not the case. Satoshi designed it to not be the case. And we, with this proposal, would be taking advantage of the design that is there to get into a position where the hypothetical best possible performance can be used by contract authors. And because we've been very conservative in the limits here, those optimizations are not required at all to implement our virtual machine.
All right. That's awesome. I was just going to make the joke before. Therefore, we expect these things that have been very common and very optimized and very powerful and spread all over the place. But now that they're benefiting Bitcoin Cash, we should expect export controls on them as weaponized stuff, right? It's too dangerous. GMP is too dangerous to be allowed.
Yeah. Further, certainly libgmp is around enough that it's not going to get any export controls in any reasonable regime. But we'll see. Callan raised his hand too. Callan, did you have something to add? Because Callan is, of course, going to be able to talk about the actual performance of C++. I can only talk in general.
The guy's name is Anatoly Karatsuba. He's a Russian guy. Anyway, that's it.
Oh, thanks.
You were right.
Oh, great. Thanks. I was like, I started saying it. I was like, oh no, I'm going to say it in a silly way, and then it's going to be
one of those words you've only ever read and never spoken out loud. Yeah.
It's funny. I mean, I'm sure I've heard it a few times in conversation, but it's not something that comes up very often. Remember, so.
All right. I have another question for you. And this relates to one of the things that you mentioned in passing, but I think it's an important point to explain. And I think you added a part of this to the chip recently. And that is, you mentioned that this is not a gas system. So
yes,
could you quickly explain
I'll take it from here.
why it's not gas, and why does that matter?
Yeah. So when we talk about gas system, people are talking about Ethereum and EVM, the Ethereum virtual machine. And to understand this, basic, the basic technical trade-offs of EVM versus where we are now is Ethereum tries to essentially optimize the ease of developing contracts. I'm trying to steel man it and be as friendly as possible to maximize the ease of developing contracts by letting developers essentially set global variables that everybody can read, and so that from kind of a very high level computer science perspective, Ethereum is a system where everybody is operating on global state, Every contract operates on the same global state. And there's, that's a little bit oversimplifying, but if you think about a single shard in even sharded EVM systems, everybody on that shard is operating as if they're like running on the same, not just the same computer, but the same single CPU core or CPU thread. So every contract is precisely ordered, and that means so every contract to understand the state of Ethereum at all, to understand where Ethereum is in any moment in time, you have to execute every contract in a precise order. And there are ways, to be very fair, there are ways to optimize how you do that. You can do some of the things that happen inside our CPUs today to, essentially do, branch prediction and stuff, and try to predict which contracts will be validated in which orders, and then if you can do the validation in advance, et cetera, et cetera. But in practice, the worst case performance of that system is that to know what happened in a block, you need to wait until a miner mines the block, or in this case now, in some instances now just validates it, right? Proof of stake. Wait until you get the block, however it's validated, and then you verify by starting from the state before the block and executing everything essentially in series. And there are ways to optimize that, of course, but in practice, the worst possible performance of that system is in series. To contrast that with Bitcoin Cash and Bitcoin, the UTXO model in general, which has other advantages, by the way, not the least of which is privacy. But in contrast, the UTXO model does not operate on global state in most cryptocurrencies. There are some cryptocurrencies that manage to use UTXOs, but somehow use global state, and they get themselves in the same global state architecture. But that's, as far as I can tell, essentially an accident, that those cryptocurrencies didn't mean to do that and they don't realize it or whatever, or they realize it and are scared to talk about it. I don't know. Hypothetically, the optimal state for a UTXO system is for validation to not require any other data. So if I give you a transaction and I give you the UTXOs it spends, you can do the validation and you can know for sure, given those UTXOs in the transaction, whether or not this transaction is valid. And when you've done that validation, you can just keep hold of the result. You don't have to check it again. And so now when the block comes in, if you see any transactions that you know about, you don't have to validate them again. And in practice, miners want to mine transactions everybody has already validated for other mining incentive reasons. Because if you're as a miner, and this is just how it works since forever, if you're a miner, you want to mine a block that everybody's going to validate really quickly, because you don't want to get made stale by another miner creating a block at the same time and then everybody following that one. So there are great incentives to keep the system moving very smoothly, and that's simply by design. That is how Satoshi made it work. So we have this just incredible advantage, and it's hard to even overstate it. Like the fact that we can validate all transactions as they come in, and essentially just cache the fact that they're okay. Instead of running the VM again, you can just remember the value is true, and actually you just drop the ones that are invalid and ignore them. And it's super, super cheap to do that, and our limits make sure that that's the case. You only keep track of the ones that are going to be valid, and then if they're in the next block, that's that much less validation you need to do. So one of these systems allows you to do the validation before you get the block, and the other system requires you, in the worst case, to do the validation, at the very least, to speculatively do the validation before you get the block. In practice, the worst case is that you have to do it after the block. If you don't have a perfectly omniscient machine running on something other than atoms, then in practice you're gonna have places where you do have to revalidate stuff after the block. Whereas
it's even stronger. It's the realistic case is that the practical case is that you have to validate after you receive the block.
Yes. Right? Yeah, I'm trying to really steel man it. But so the difference between these two systems then is that in one, the computation cost is almost irrelevant to the functioning of the system. That the UTXO model, it's almost irrelevant. It is relevant still for denial of service purposes, but it is from the context of like how relevant it is in a global state validation architecture. It is essentially meaningless compared to a global state architecture, because global state, you need to be thinking about minor incentives based on how quickly the computation happens. And so the precise cost of every single computation, no matter how silly and trivial, is an immediate and global concern for the whole network. And so in practice, just by the architecture itself, the thing that really can't be changed, you can shard it, but you can't really do more than just kind of like break it up into smaller pieces. In practice, the architecture itself means that always and forever, whatever difference there is between, and here's the steel man, whatever difference there is between the number of UTXOs being validated and the number of shards in the EVM system, that difference will be the worst case performance difference that we don't have to care about as a multiple. So let me say that now, not Steelman. In practice, Ethereum developers can think of Bitcoin Cash as having transaction level sharding. That's what it actually means. We have transaction level sharding. You cannot shard less than. I mean, actually, we have less than. We have input level sharding. Let me actually be more clear. Well, we have mostly input level sharding, but we also validate the transaction as a whole too. So it is actually possible to validate inputs, in parallel, and we're maintaining that possibility. But if I'm just trying to keep it simpler, we have. On Bitcoin Cash has transaction level sharding, and then many of the other same tools you would expect, with the exception of loops right now. So we do have something we still need to work on, I would say. Something I would still say is deficiency versus EVM, but it's only really applicable in a subset of contracts. Many contracts don't need that. Obviously, they're not using it right now, and it's possible to build a lot of things with essentially hand unrolled loops. It sounds ridiculous, but even our current system, we've been working with a whole lot less for years. So getting past where we are now, getting limits and big ant, it does. If these upgrades were to happen, it would feel very good. And I would say that our only remaining deficiency then versus the EVM systems is that for a subset of contracts, our contract length can increase in a factorial or polyfactorial way. Our contracts get really, really long, and they get longer if you have to do more condition checking in the middle of some loop somewhere. But again, most
reasonable. Even with the kind of static analysis, you would be like, yeah, whatever, that's fine, that's reasonable. Yeah. So I mean, we are we're getting very close to equivalent on the contracting side specifically, and the validation side is the place where Bitcoin Cash truly really excels. Obviously, for those reasons that we can, at least theoretically, based only on the architectures, if we are a little bit less precise about it, we theoretically can allow contract authors to use tens or hundreds, maybe thousands of times as much computation per contract as a global state architecture can afford to give their contract authors. And those are based on the fundamental realities of the architectures, not on specific, benchmarking or specific implementations of code. There's one of these is parallel and one of them is not. Okay, awesome. Yep. So thank you very much for that. Do you mind if I go on to a completely different question?
Yeah, sure. Did I answer maybe I didn't answer the gas system. So
The
sorry, let
gas
me
part, yeah,
complete.
maybe you
Yes,
could
let
do
me
the gas.
complete the answer. Yeah, so I was thinking about it. So I'll complete the answer. So given those fundamental realities of the architectures, we have no need to carefully measure the actual computation used by each contract. All we need to do is make sure that none of them use too absurdly much. And most contracts just can't even get close to the amount of computation that, even with these very conservative limits, that they would be extended. Most of these contracts are simply never going to get close. The only way to get close is to do essentially very large computations using big int. And I do expect that in the future there will be various contract use cases that people will be able to give very specific use cases and talk about, hey, we want to reduce the cost of mole to be what the optimized implementation should be. Here it is. This is and giving a very good case for why this is better, because it'll reduce bandwidth on the network and et cetera, et cetera. It'll improve the overall performance and reduce the wasted cycles that the CPUs have, et cetera. But so for right now, our limits are set super conservatively so that you don't have to have any optimizations, any meaningful optimizations, hard optimizations, I would say, in the virtual machine implementations. But it is possible for us to push it quite a bit harder. We are definitely walking before running.
Okay, perfect.
But yeah.
And
so
I just want
to
add
make people pay for computation. That's the answer. We simply don't need to make people pay for it, because the amount that we can afford to give them is just so much higher that is not even worth us like dealing with the complexity of doing that.
Perfect. Thank you. Yeah, that does answer the question. And I also wanted to add an addendum that even though there may be limits to what can be done, that doesn't limit what can be done in one input or in one transaction. That doesn't limit what you can do overall. So in line with what you were talking about EVM, you can spread, if you do happen to have a particular use case that requires a lot of computation beyond what is normally expected or average, you can still do that by composing multiple transactions. So it's still possible to do more complex things than even the limits are allowed in some very rare cases.
Yes, and thank you very much, because I forgot to bring that up specifically. And I'll give as an example, the demo of the demonstration of a decentralized exchange that I put together in 2022, called JetX's Joint Execution Decentralized Exchange. It's essentially just a demo of a lot of different, maybe not immediately understandable contract constructions that are available to contract authors. I wanted to do it as just a big example of all the stuff you can do, and it specifically uses, I think it's 8 contracts. But I just wanted to say that because the fact that we give essentially I want to argue against the true steel man of the global state architecture. We give contract authors essentially one level lower level access to being able to optimize the resources they require of the global network. So like the contract authors can, in the case of JetX, because there are eight different contracts, most of the kinds of transactions you would create with a JetX instance have inputs that are smaller than a single signature spend. They're literally smaller than the spending a normal address. The contract, including all the code you need for that part of the contract, including all that code in the transaction itself, having it be read and validated in the transaction, contributes less to the size of the transaction than a single signature spend. And it is actually difficult to imagine too many contract constructions that cannot be optimized to that level, because fundamentally, when you have different code paths, you can put them in different UTXOs or UTXO categories of UTXOs, sort of, in your multi-input state machine that is a decentralized application. you can have a UTXO that users use to deposit money to the decentralized exchange, and that UTXO can be interacted with a transaction that requires, of course, one input for your single signature spend, where you send the money from your wallet, and then one other input, which is like 12 bytes beyond the out point. The 36 bytes that the chain uses to tell where the UTXO is, right? So like we're dealing with things that are really at their very peak optimizability theoretically in any system that worked anything like a cryptocurrency. Like the UTXO model is just incredibly efficient, and you can break contract systems up in ways that are counterintuitive to people who think that if you build a contract this system, because you're using UTXOs, it wastes a lot of bytes on chain. That is a completely believable expectation that if you have to write the contract and then the contract is sitting in the transaction and the transaction gets validated, then you'd think, well, okay, that's a lot of duplication, right? All those UTXOs have the same contract. The number of bytes used to write the contract in many cases is less than the number of bytes of a hash you would use to reference the contract. So to argue with that direct steel man, you would be shocked at how many decentralized applications can be broken up into parts that are actually quite literally at a byte level more efficient to do in the UTXO model than they would be if you uploaded all the code and everybody looked at the same block of code and referenced it by a hash, because the contract is shorter than the length of a hash.
So I don't know how many of our listeners can appreciate what you just said, but I think it boils down to a kind of a repeat of the statement before, which is how did Satoshi make? I mean, he obviously made some not perfect decisions, but how did he make so many good decisions in the design of this setup? It's kind of ridiculous from the byte arrangement of numbers to the limits to a lot of points here. Okay,
For the non-technical listeners, imagine an arrangement where it's literally cheaper for everyone to buy their own car rather than sharing a single car.
Right,
that's a great example.
That's a great one. Right.
Yeah.
Okay.
And the advancement being that, we just bought a fleet of buses, which is sharding.
As Uname often says, all the sharding stuff and optimization in EVM is like doing their level best to revert to a UTXO model, right? At the end of the day.
And actually, I didn't mean to say that when I was talking about JetX. One of the other things I wanted to demonstrate with JetX is that there is an entire design space of contracts that are not really possible on a system that doesn't have access to the UTXO model. If you have to use global state, if you're forced to use global state, if you don't get to use UTXOs, then there are some kinds of contracts that you have to emulate UTXOs to have them work as well as they work on Bitcoin Cash. And JetX is an example. You have to actually emulate it, and in practice nobody's ever going to do that because you have to pay for computation, and you don't want your users to pay like $100 in transaction costs for every transaction. So and in practice everybody's using multi-sig admin keyed L2s anyways, but if you are still going to use the base chain, it would be very, very expensive to emulate the UTXOs required to even build the kinds of constructions that are the most efficient constructions on Bitcoin Cash.
Excellent. We're going to leave that one for the history books to document. Let me ask a completely unrelated question to the VM limits and the big int and all of that. But this is a topical discussion that comes up repeatedly in BCH. So if we forget about the zero conf escrows, like that whole setup, if we forget about that, there's a lot of people who have this issue that they say confirmations are too slow. So services that I use take too much time with BCH because everybody else is doing, 10-second blocks or 5 microsecond blocks or whatever because they're on some kind of proof of stake system. So I want to know, if you forget about zero-conf escrows and similar setups, what is your thoughts about people who say, oh, BCH needs Avalanche or BCH needs some hybrid with proof of stake or just needs to go pure proof of stake, or just your thoughts on that whole topic area of what do you think about that issue and the solutions to it, and particularly the proof of stake related solutions to it?
Thanks. Yeah, I'll
don't
careful here. Yeah,
don't feel the need to
choose exactly what I want to say, but
don't be afraid to hit the nuclear button either. That's also totally fine with me.
I would say there's two parts to that I have to mention both for it to be sensible. First, ZCEs is a very important part of why I'm okay with my the other review I'll give. So zero confirmation escrows, and I think you used the word setup when you said zero confirmation escrows, and I just want to note that they don't require any setup. They can be spent directly from P2PKH outputs with no setup. They provide immediate finality as good as one confirmation, and their only trade-off, their literally only trade-off, is you have to have another times the amount of money you're sending. So if you're sending $10, you need to have $10 more worth of Bitcoin Cash in your wallet. And the $10 you sent goes to the merchant, and the $10 in the zero confirmation escrow gets put in another output that your wallet can immediately spend. It doesn't get locked up. Your wallet can immediately spend it in another zero confirmation transaction. It doesn't need to be confirmed. There are no further requirements. And so in practice, the only true cost is that your wallet needs to have twice the amount of Bitcoin Cash that you want to send with instant finality. And there are a few different ways of defining finality, and I've described them extensively in that 2021 with Marty in the chip that I published with Marty in 2021. So please take a look at that. There's some rationale about exactly what finality means if it's better than one block confirmation. There are cases where I think we can prove also it's better than 10 block confirmation, that we can prove it's as good as Avalanche would be. But there are risk models to consider. But from a lay user perspective, there's a very safe path that you can say has as good as one confirmation instantly, with the only cost of needing to have in your wallet twice as much as what you're trying to send. I think that's a pretty good, and you can also immediately respend the money that you just received in a zero conf transaction, and you can spend up to half of it in another zero conf transaction. And then if somebody tries to double spend either of those transactions, a miner has a greater incentive to mine the ZCE transaction, which pays the merchant. So the merchant gets the money, right? The merchant ends up getting the money even if you try to double spend it, because the miner will take your money and also give the merchant their money, right? So, and it happens for chains of ZCE transactions as well. The incentives work for chaining as well. So it does meet the meetup, the design, what I would say is the design spec of a meetup use case. Like, hey, you just learned about Bitcoin Cash. Here, download a wallet. I'm going to send you $10. And I send you $10, and the ZCE has $10 on there. The $10 ZCE is immediately back in my wallet. I can immediately spend it somewhere else. I just have to wait for a confirmation. But that user that I sent the $10 to with a ZCE transaction, they can then turn around and make another ZCE transaction with that $10 and pay $5 for a drink and put $5 in the ZCE. Now they have $5 in their wallet that when it confirms, they can use it however they want as for more ZCE transactions, or they can immediately respend it and send it back to me, right? Like I can be like, hey, I'll give you $5 to buy a drink immediately. You can immediately use the ZCE money, and you can also send me my money back. And we're talking to each other, so we have some base level of trust. But the merchant doesn't necessarily have that base level of trust. The merchant might be in a place where the rule of law isn't necessarily guaranteed, or they can't manage the costs of fraud or something. I mean, there's lots of reasons merchants wouldn't necessarily be able to trust an in-person payment, and you can immediately send somebody an in-person payment that has finality that merchant would accept, and they can give you back the bounty immediately that was required to make that finality work. So I just want to clarify that, like, I am fairly confident that is. I put Marty and I worked on that quite a bit. It's downstream of lots of other developments. It's something that most people still to this day, when I describe it, most people are incredulous. And I'm sure there are people on this call right now and people that will listen to this later who will be like, no, that's not possible. Surely that's not possible, because we've been trying to do that since forever. And it is true. We've been trying to do that since like Bitcoin Talk Forum days. People are talking about it in 2011, 2012, 2013. I mean, and then there's like a university paper from somewhere in 2015 where they do it with some clever signature stuff. And, people independently rediscover signature-based confirmation escrows like once a month or maybe once a year. There's a different group of people that independently discover it, and they're like, "I found it! I discovered it!" It's like, yes, that's what they put in the 2015 paper. And then Bitcoin Unlimited had another discovery in 2019 that really moved it a lot further: zero confirmation forfeits, and it got so close. It was so close, but did not quite get the incentives fully figured out. And honestly, I've kind of forgotten the places. You'd have to review them both and check. But there are a couple other pieces that really fell into place on Bitcoin Cash specifically. How we thought about doing double spend proofs and some other things that kind of finally happened with the contract system. Introspection was critical for the most optimal implementation of treeless ZCEs. But yeah, the puzzle pieces really fit together to actually solve that use case, I believe. And I would challenge anybody who disagrees with me on it to please review that. I put it out with Marty 3 years ago, and nobody has told me that it's wrong, but also people don't necessarily believe it. So I'm just going to say, the best way to get the right answer is to say the wrong thing on the internet. I believe definitively that you can get one block worth of confirmation finality instantly, actually faster than credit card transactions can possibly happen. Credit card transactions, you have to put your credit card wherever, and the terminal contacts usually a payment processor or contacts a bank, and they contact the payment processor, and sometimes there's like extra steps, and then it comes back to the merchant, and the terminal like spins and spins and spins, and it says, okay, payment confirmed. Because fundamentally, like you're actually dealing with the laws of physics. Like you have to ask the bank, and it has to come back. And if you're like, if that ping time is slow, then it's actually going to have high latency. Whereas a zero confirmation transaction, I further claim and challenge anyone to please review and disprove. I further claim that it is possible to immediately consider it final without checking the network further. If you were already listening to the network when you heard the transaction, the period of latency when you would otherwise have to wait for that 200 milliseconds or whatever is no longer required, because with certainty that everybody has an incredible incentive worth the value of the payment. And I think I could steelman it and say there's one other case that's discussed at length in the proposal. So go look at the proposal if you think you've got a clever solution for how to break it. But I'll say that the immediate finality is as good as one block confirmation, and you can believe it is final to that level the moment you read and verify that the transaction has the bytes it's supposed to have. You do not have to sit and wait and check the network or listen for another thing. The moment you pick up that ZCE, with certainty that if they do try to double spend, the miners will take the money from them and also give you your money. Because that's how it works. So yes, I want to say that in the most aggressive terms possible. If you do not agree with me, then I challenge you to disprove it. I don't know how much longer that proposal needs to sit out there before people will start to believe it.
So Jason, I'm regretting my life choices here about the way that the words that I chose to describe zero conf escrows. But can I summarize from that yes. That the therefore after that would be, why do you need anything else? Why do you need to worry about anything else? The problem is solved.
I question that as well. Yes.
Yeah. Right. So we won't get into the nuclear topic of proof of stake and why you would need such a proof of stake system.
I'll add a little bit because I was talking to some other people about this offline just recently. But I'll add, and I'm because I know I'm already on the record saying this in the past, that I think there is a fence there in the vein of Chesterton's fence, where people should really recognize that in the Bitcoin system, I think brilliantly, miners do not need a stable network connection. That in the worst case, miners can actually, can actually hide and mine blocks, and every once in a while throw a block into the air over one connection and then get rid of the connection. And and they can physically move their boxes, like and
can join and leave at will, right?
Yes, right. And I think people are a little bit complacent, maybe, in the shadow of how brilliant that is, because you have to recognize that the credible threat of being able to do something is, in a game theoretic sense, just as important as having actually done it, right? So the fact that Bitcoin Cash can do that is itself protective, because if you believe you're going to somehow censor the network by going after the validators, going after the miners, you need to have gamed out what the worst case scenario is, and the worst case scenario is pretty bad there. Right now, the miners are regulatable. They're above board entities. People you can see, and for a while you could detect the heat signature of miners from space, right? But now, of course, you can't tell what's AI training and what's not. So I don't think that's a very good argument anymore. But I think people undervalue the fence that is there. There is a fence there, and the fact that it has never been tested is, by the grace of God, and also by the fact that either Satoshi had thought about that, and that was part of his design, or a number of other previous systems had thought about that, and it was kind of downstream of kind of the general movement of censorship-resistant peer-to-peer cash. But I think it's very easy for the existing cryptocurrency space to assume that there don't need to be protections that have never needed to be tested, because we lucked out and they didn't need to be tested from the beginning.
All right.
Are you muted, John?
Hello? Can you hear me?
I'm completely muted. Yeah, I was talking to myself.
Did we get cut off? Oh, no.
No, I was.
All right, we're good.
Sorry for that.
I was worried somebody
pulled the plug. He's just demonstrating that he can join and leave at will.
Yeah, I can join and leave at will. Yeah.
Yep.
Perfect. So let me keep going down the list here. So on a totally different topic, not on the technical side, you've mentioned that you contact a lot of people. And then we also, regarding the chip, the cash improvement proposals, the specific format for how we're kind of activating things in consensus on Bitcoin Cash. With regards to that, you've mentioned how you have contacted many people. And then Jonathan is also here, who has been involved in the chip process and been the owner of a chip and made sure that things happen on a chip. Could you speak a little bit to that? Like, what were you talking about? You're saying you're contacting a lot of people, looking for feedback, and the chip process itself. Like, could you say a little bit more about that? Like, why you contact all these people, why it's important, what your thought process is on that?
It's thank you. In order to have an upgrade that goes smoothly, well, actually, start with the quote that if you want to go fast, go alone. If you want to go far, go together. In the context of upgrading a system like Bitcoin Cash. Am I disconnected again? Can you hear me?
No, I'm hearing you. I'm hearing you. Yeah.
Okay. Yeah. The interface fully froze, and I'm sorry. Okay. I'm just gonna keep talking and assuming that I don't get cut off, and I'll have to re-say anything that gets cut off. So yes, in the system like Bitcoin Cash, where there's a large existing user base who have really good, human consensus on, hey, this is money and this is how peer-to-peer electronic cash should work. And there's also another substrata of developers and businesses and miners and marketing and podcast and social kind of layer people, all who agree on what it means to be Bitcoin Cash. It's very easy to make upgrade proposals that start from nothing. And if you have a blank slate and you get to do your own cryptocurrency, it's super easy to make your own cryptocurrency, fork something, and just change all the rules however you want. It is quite something else to adequately convince all of the above that there is a present need for a real improvement that doesn't hurt any of the existing use cases. It's just an improvement. First, do no harm. You want to convince absolutely everyone in the most unsurprising way possible, so that everybody is just excited and on board. And then by the time the upgrade is come around, no one feels surprised. There's social concordance that it's an altogether well-reviewed, well put together upgrade that makes Bitcoin Cash better. And the chip process is like formalizing the right way to do that. The right way to do that is to first come up with your proposal, have a pretty solid idea of the proposal, but then announce it and try to find stakeholders who will care, all the people that might care, and go ahead and let them know that you're working on this. And in the case of the VM limits, it's it was proposed in 2021, and that's when initial broadcasts, and I directly contacted all of the people that I knew of that were working with Bitcoin Cash contracts, and I wanted to hear like, hey, what do you think about this as a solution to the 201 opcode limit, et cetera, et cetera. And then there are all sorts of kind of marketing or business or representatives of mining companies, things like that, who end up involved in various stages where either ideally you want to try to find some of them. It's obviously, for a network like this, it's impossible to just directly message everyone, but you want to try to contact as many as you really can. You want to make sure that there are no like secret pockets of discontent with the proposal itself, so that by the time you get around to November, when lock-in needs to be, and for us, for October, you want it to be the beginning of October. You want it to be nailed down. You want all the node implementations to have started on it, all the active node implementations to at least have started on it, but certainly for it to be production ready, or very close to production ready on node implementations that are going to be relied on by at least chipnet infrastructure. Now we have some backups as well. So I mean, it's fantastic that we can get stuff locked in on the kind of the social level in October and November, because then in November we activate it on our chipnet testnet, and then everybody can test it in essentially production, where everybody has a shared vision of production. Chipnet is a shared production for 6 months. And then if anything's broken, it can get fixed for 6 whole months. And we've already resolved the human social consensus thing 6 months early. So instead of there being like a website where there's like miner signaling and everybody's like, hey, if all the miners mine enough blocks that say this, then we're all just going to probably go along with this, but we won't really know until we see what the exchanges do, and they might still double cross. And yeah, actually, I have no idea what's going to happen on upgrade day, right? Like, I mean, before this process was really messy. And the only other alternative, of course, is just having like an overarching foundation, right? It's like, and that's essentially how all of the other cryptocurrencies that do not follow a process like this, that's how they upgrade. They have a centralized team. Yeah. So having that 6 months of ChipNet is fantastic for getting people who you gotta also remember that it's not even worth implementing the upgrade until people are certain or pretty darn certain that the humans consensus has happened, right? And so you also have to understand that upgrades have this chicken and egg problem where you got to get a huge amount of support for a particular upgrade. And then it needs to be so great that you have multiple implementations already implemented before, speculatively, and test it really well speculatively so that they are ready if it does get upgraded. And then there's kind of an outer circle of other products that in most cases shouldn't be affected at all, but by any upgrade. You don't want to break user space at all. That's the important thing. But in practice, they do still have to make upgrades. They have to, some people have their own custom patched nodes that are doing different things, and they'll have to make changes to those. If they have a custom patch node, they'll have to make changes to those by May if an upgrade is locked in November. And ChipNet gives them an opportunity to make sure that nothing's terribly broken. And when ChipNet upgrades, a number of developers will try to send transactions that test the limits and make sure that anybody who just connects to ChipNet will see really quickly in their system if something's broken. But yeah, this process overall just of trying to get people involved very early and go ahead and root out any pockets of and even it's also important to understand if there are other ideas that would simply be better than your original proposal. And there's not a single chip that didn't get significantly better over the course of the process. This one included. This one has gotten massively better since 2021, and especially since February when BCHN essentially kicked off the process again. It essentially sat dormant until a number of contract devs were started kicking around on the forums and eventually prodded me into working on it again. And only after BCHN had implemented the tests. So I mean, it's these processes can take a long time and they can bounce a lot of ways. But the important part of getting those stakeholders involved super early is to be able to do it together, so that by the time you get to the human consensus part, it's not going to be a vote. Of course, it's not going to be a vote. It never could be. We could have the semblance of a vote, but understand that even places that have votes, even countries that are democracies, have revolutions. So voting is not the solution. It is one of the solutions. There is a voice and an exit side, even in democracies, and whether or not we pretend there is. And this is the chip process is sort of a way of taming what would otherwise be revolutions. And voting would be one way to tame it, but also most people don't agree that voting is a good way to do it, right? It's not the case that a simple vote would produce the best technical specification. Everybody sees what everybody else is saying in the chip process, in this long drawn out process, where then at the very end, when we know exactly what the spec looks like, there's multiple implementations, and then people start putting their public on the record statements up so that everybody can see what everybody else is saying. Typically there's a just overwhelming consensus, and even by the time you get to here in the process, it's very difficult to get to here and even start to collect those final statements on the final stack of the very final implementations, and having people are wanting to review BCHN, the patch. They want to review exactly what we're going to be expecting our mining base to run in May before they thumbs up a protocol proposal in October, right? So even when you get there, you need to get lots of very public support, such that everyone can see what everybody else said at this time on the record. Public. This is like a very public process, and then ideally by the end of October, it should be just abundantly clear that everybody in the space, or a significant economic majority, plans to do this upgrade come hell or high water. Right, and then it changes the incentives for everybody else who was may have been not bothering with even implementing it in some specific thing. If you have, for example, developer tooling, LibAuth, I didn't even need to implement Abla for a long while, and now I had a public statement of support on it, so I was excited about it. But there is there is kind of two sets of software there, where some people do actually have to get their implementations done to really evaluate and know that they are good with this upgrade in November. And then there's another set that it's incredibly helpful to have this really public, social, on the record process, where we also reach out not just to like all the people that we know are like currently involved in Bitcoin Cash, because that's not the bar either. The bar is what all of the people out there who believe that they're holding Bitcoin Cash right now, what they will accept as within the overtone window when May comes around. When May comes around, it's got to be completely abundantly clear that if there is a conspiracy to sabotage Bitcoin Cash again by breaking it on a technical level, that we can see what everyone had already said on the record 6 months earlier. And so now the sides are reversed. Now the people who were trying to do the honest and the honest thing have a good way to coordinate on the consensus before it's like a crunch time, like, okay, what's going to happen? This is the last week. Is there going to be an upgrade? It should be so far beyond the overtone window by December. Like after November, it should be by December. It should just be super obvious exactly where Bitcoin Cash is going to be, such that even if there was a cabal of exchanges and one particular large business and some of the developers of the lead implementation, even if they decided that they wanted to kind of slip something under the nose of the existing user base, it would be so far beyond the pale that they would not get away with stealing the ticker again.
Yeah. I can say that from I guess, because that's from the protection, right? Defense perspective.
Yes.
But if you can also look at it from the forward-looking kind of positive perspective, where like if you look at Bitcoin Cash ecosystem as a decentralized organization, you can do things in such a way that people hate it and they leave, and that's not good. And then you can do things in such a way that people think it's not so bad, but they don't have another alternative, and that's not great. That's not a great place to be. And then you can do things in such a way that people become loyal, right? And you will never have everyone happy. That never happens. So this isn't like a kumbaya process, right? Where you're looking for every single person to be happy and rainbows. But if you have the vast majority of stakeholders being not only, well, okay, this is the only thing that works, so I guess, but actually being loyal and being like, yeah, this works. I like this process. I like how this chain makes decisions. That's where we are with the chip process at this point. So I'm very happy with where we've gone so far and where we're going.
Yeah, for sure.
Can
And you just get better upgrades too. I mean,
yeah, exactly.
Literally, we've made some serious improvements in every single upgrade has had very serious improvements in this kind of the 6 months, especially the 6 months leading up to October, when we try to have, technical details should be finalized October, so that you have nobody can even claim that they didn't have a whole month to review it, right? I mean, that's what it's not. You're not dealing with what is effective. You're dealing with what is the worst case of what someone could claim, and then have a plausible claim to victimhood, right? And that is where we want to make sure we have super strong consensus process for the human stuff, even though the human consensus processes are tough and uncomfortable, and nobody actually likes them, no matter how small the consensus is.
Yeah.
Hey, yeah.
Tether needs a new pair of shoes. I don't know what you're talking about.
I don't think I named any names.
I didn't name any names either. I mean, that's like that's a word in the dictionary.
Oh, sorry. Okay, got it.
Richard actually has joined us. I'm not sure, but Richard, did you have a question you wanted to ask for the AMA, or just something to bring up, or
no,
wasn't able to?
I might have accidentally requested to speak, but that was just because I was switching to my phone to take the dog for a walk. I think it's a great proposal. Don't really have any questions. So
thanks so much for reviewing it. It's fun.
Well
it's great to have you back reviewing it. Also, I know it's been a little while.
Yeah, I do drop in and out, don't I? But no, it's a great proposal, and
Thanks.
looking forward to see what comes of it in terms of the applications, right? So, I'm one
Awesome.
of those people. I love the details at the protocol level and transactions, and but also super excited about what the community is doing with applications. I know you've also got a lot of your own ideas, Jason, about applications. And you've said a lot of really interesting things. I'm particularly interested in some of the things you've said about currencies and the importance of deflationary currencies. Do you have any ideas? You've done JEDX, obviously, as an example application. Do you have any other ideas knocking around that you kind of want to work on as proofs of application, or do you want to stay at the kind of protocol and chip level for the foreseeable future?
Great question for a dog walk. Congratulations, man. That's great.
That's a great question. Yeah. Thank you for the question. I don't have anything to share right now that I haven't shared already. Obviously, there are lots of things to be thinking about. I try to get things to a level of readiness that is beyond anything I have currently right now before I go out and say that some particular thing is possible or a good idea or something. So I'd say right now I am most excited about ZCEs. Obviously, it's definitely on my list. As once we get these limits fixed, if this process is successful this month or so, and Big Ends especially, I look forward to not having to do many chips ever again, because we're going to be real close to everything that I see as clearly missing, things that are obviously missing. Things after this are we're getting a little thinner on stuff that are, places where we're behind one other cryptocurrency or another. I mentioned Loops a minute ago. Loops, I think, does need a chip. I don't know if I'll do it. I might let somebody else do it. I'm a little tired. I'm excited to work on applications too, because I think there are some novel constructions that are only possible on a UTXO model like Bitcoin Cash. They're not even possible on other UTXO models that break their UTXO model by having some global state, right? They're not even, they're at least not as efficient on those models. So there's some other, certainly top 100 coins that claim to be UTXO models that have deficiencies that wouldn't be able to do some of these things. But there are definitely some DEX, decentralized exchanges, some automated market maker systems that would be truly unique to Bitcoin Cash and would be and to a well-designed UTXO model. Like in some ways, all of these models can be interchangeable if your development is sufficient. Like the way you approach it, as long as you stay within kind of the bounds of the specific architecture, every sufficiently developed UTXO model should look pretty similar. I just have the opinion that Bitcoin Cash is a little bit further ahead than any others in that particular set. So
I have the same opinion.
Yes. So I think there are some novel decentralized exchange constructions. Obviously, I've said that I'm excited about prediction markets in the past, and then I'm also very excited about ZCEs simply from a user experience standpoint. Like I think there is just a huge area there to be grown, and I'll say also there is a set of contract constructions that use the model that ZCEs uses for pay to public key hash. The ZCE is a specific construction of a more general idea, and ZCEs are, I believe, the treeless ZCE construction is either perfect or near perfect for the validation it tries to do. And I would appreciate reviews of that as well. But that is a specific What's that?
Chip back. I'm glad you brought the ZCE chip back up, because I do remember seeing it a year or two ago and need to go back and review it. So
Sweet.
hopefully I'm not the only person that will go back and take a look after this. I do remember thinking it was super neat at the time, and I remember the Tom Zander.
Too good to be true. Most people thought it was too good to be true. No, it's fine. And then between the people who thought it was too good to be true and the people who were uncomfortable with the 5-second relay period, because they associate it with like RBF, they're replaced by fee stuff. which is certainly is not. Replaced by fee becomes an actual issue for zero-conf transactions for the remainder of the block before it's mined. But in the case of a fast relay, there's a good argument to be made that it is pro-social to fast relay the confiscation transaction that pays miners. That's a great thing, and the network should relay that. For 5 seconds, and there's a specific discussion of exactly the incentives and who needs to be aware of it, and specifically that it does not impact any existing use cases, because any existing use cases that are secure at all should already be listening for 5 seconds. And that's from the Bitcoin Unlimited's research in, I think, 2018 or something, and it's discussed in the chip. So I would love to hear the feedback there. But the reason I brought it up again is that the ZCEs are a specific construction applied to pay to public key hash transactions, a specific construction applied to single signature addresses that can also be applied to a very wide variety of other contracts, like decentralized exchanges. It is possible to do stuff like what ZCE does, bounty systems confiscatable bounty systems that can improve the finality of other contract systems. And I think there's a big area to be explored there.
I wonder if it
nothing to share.
Some minor extractable value problems.
Yes, most certainly. So it's not easy to just say there's a lot of complexity to unpack when you say like solving minor extractable value, but I would say that
mitigate.
The steel man is that Bitcoin Cash has far more tools and constructions and game theoretic options for mitigating them than any global state cryptocurrency currently has.
Cool.
I was going to translate the answer that, what are Jason's plans? I think the hidden answer is he has plans for world domination, but he just can't tell you exactly.
No. I do not have that. I don't have anything that's sufficiently working. And if in any of these paths, like, and when you mess with this stuff, and when you write a chip, you'll find that until it is 100% done, even that very last 1% can just scrap the whole thing. And so, let me be more specific. I don't have any projects that are not possibly scrap. And I would tell you if I did, but I'm not going to tell you before I do, because I'm not going to overpromise.
Yeah, and interestingly, in the case of PMV3, it wasn't that something in the last 1% made it infeasible or caused you to scrap it. It was actually that something in the last 1% gave you a bit of a eureka moment that led you to discover something even better. Is that right? Like PMV3?
Yes, exactly. Yeah,
worked,
PMV3.
Right?
I mean, PMV3 went through the chip process for a while, and then at some point, quite literally, it's like, oh man. Oh, actually, the whole reason I was doing this was so that I could have this, 700 byte contract or something like that. Like, what if we just let the contracts give each other messages? It's like, oh man, oh gosh, the token guys are right. Oh boy. Yeah, for sure. And then I immediately contacted the guys that were currently excited about tokens as a standard thing. I was like, hey, I think that I just independently stumbled on where I need tokens. So you want to work on it?
Yeah, it was a classic thesis, antithesis, synthesis.
Thank you. Yeah, it's
tokens and then PMV3 and then cash tokens, or group and then PMV3 and then cash tokens or something like that. Yeah, very cool.
Yeah. Yeah, I was joking with somebody that, by the way, I've proposed quite a few chips that some of them I have withdrawn. So, I also have the highest withdrawal rate so far of anybody. But if we're talking about just stochastic probabilities, these chips don't have great chances. But I feel like technically we are there, and also consensus wise, like, these things have been a long time coming. Nobody is surprised at all that we want to find a better solution than 201 opcode limit, and there are a number of chips that have proposed ways of getting to what we have with Big Int. So I'm not gonna pretend like it's a done deal. This is where the final lap begins. But I'm cautiously optimistic that this month will be good, and that hopefully by November we'll upgrade ChipNet and everybody will just get to play with this stuff.
Excellent. So, Jason, we're over 2 hours now, and I still have like a long list of questions to ask, but we should probably wrap it up. But
yes.
I wanted to ask before I wrap it up, was there any points that, through this discussion or just otherwise, that you would like to get across, or you would like to make sure that get heard, something before we wrap up?
I think we've covered a lot of the big stuff, and I would love for people to, if there are other questions, I will enjoy responding to them on the whichever subreddit, RBTC, for on Reddit, the AMA there. I'll keep trying to respond to questions here for a little bit, and then even if I have to check out for a little bit over the weekend, I'll come back and respond to even more on Monday and Tuesday and such. So if there are further questions, I would love to answer them there. So some of the answers end up becoming, places where I realize we need to add a little bit more explanation someplace in the chip. And even if everybody who's currently around understands it, there's a lot of frustrating stuff in the past of Bitcoin where it would have been nice if we had chips to review the rationale, right? Whereas you have to, do some excavation. And in some cases, you need to just email Gavin or whatever to ask like, hey, did you know about this at the time? And I have done that. And he's like, I searched my email and it's not in there. So, it'll be very nice for Bitcoin Cash to have also some documentation of the rationale behind some of the things that are improved by chips. So yes, questions are amazing. Even questions that feel like they're very basic, because if you have a basic question, it means that the chip doesn't answer it fast or cleverly enough or something. Like if it was ideal, then there should already be an answer that I can just link you to, right? So if I have to write an answer, then there might be something that we can add to the historical record for the large language models to consume later. But anyhow,
that Steelman approach to it. That's great.
Yeah. So thank you so much. I will look forward to more AMA questions, and I have to hop off now also. But yeah, thank you very much for hosting.
Oh man, thanks.
Thank you very much.
Yeah.
Awesome. See y'all.
All right. So we're going to wrap up. And thank you everybody for joining us. And of course, we'll be back next time, and we'll be online as well to discuss the VM Limits chip, the Big Int chip, and anything else that's going on in the BCH ecosystem. Thank you so much for joining us, Jason.
Thank you all.
Take care.
Thank you.